Hello friends, today in this session we will discuss extra clearance required on a horizontal curve in different situations. And the first situation is, or first case is, the extra clearance required because of curvature, due to curvature. When a railway vehicle negotiates a horizontal curve, because of rigidity of the wheelbase and because of the rigidity of the total frame of the bogie, it does not take the shape of the horizontal curve. When the bogie is in this position, that this is the rear wheel of the bogie and the front wheel of the bogie. So this is what is called the overthrow. And it is because of rigidity of the structure of the body of the bogie. And when at the end of the curve, this is the end throw. This is end throw. Now this is inside the curve, and at the ends it is outside the curve. And therefore extra clearance is required in case of horizontal curve, inside also and outside also. Let us say this is C, that is center to center distance between bogies, and this is overthrow. If you take this as a circular curve of radius r, then this overthrow can be written as C square upon 8r. Overthrow will be C square upon 8r. R is the radius of the curve. End throw. End throw here is given by this equation. End throw is L square minus C square upon 8r. Now here in this equation, L is the length of the vehicle and C is the center to center distance between bogies. R is the radius of the curve. So due to curvature, you have overthrow, which is inside the curve. You have end throw, which is outside the curve. So at the end of the you need this clearance both sides. You need clearance both sides of the curve, inside as well as outside. Second is due to leaning of the vehicle. Leaning of the vehicle because of super elevation. When a vehicle moves on a horizontal curve, while discussing the amount of super elevation required, I told you that we provide the cant, and this cant is basically by raising the outer rail by certain amount. And when you have the bogie placed on two rails and one of them is at higher elevation than the inner one, then in that case there is, now this is the bogie placed here, whereas in case of a normal tangent track or a leveled track, this will be like this. This bogie will be flat. This will be like this. Now this is basically the leaning of the bogie. This amount, it is because of super elevation, that is the lean. So you need extra clearance inside the curve because of super elevation. And This you can find out if this is the amount of superelevation provided here. Amount of superelevation provided here is E, and this angle is alpha. This is G. Then tan alpha is E upon G, and same angle will be here, alpha. And if this is the height of the bogey, then tan alpha will be L upon H. This is L upon H, and therefore the lean will be EH upon G. E is the amount of super elevation, H is the height of the bogey, and G is the gauge. It is not dynamic gauge here, it is some normal gauge. This extra clearance because of super elevation is on inside of the curve only, it is not outside the curve. Okay, and height of this bogey will depend upon the gauge. Then the third one is effect of sway of vehicle. Sway of vehicle. Now, while discussing the cant and cant deficiency, I told you that we provide the super elevation on a horizontal curve corresponding to equilibrium speed. But actual speed is not equal to equilibrium speed, and therefore actual speed is either larger than equilibrium or lesser than equilibrium speed. And therefore the cant provided is either in excess of what is cant required or it is indeficient. Now that is the concept of cant deficiency or cant excess. This we have discussed in our earlier session. Now because of this cant deficiency or because of this cant excess, there is always a sway in the vehicle, horizontal sway, and because of that it leans outside or inside because of excess of the cant or deficiency in the cant. Now what Indian Railways suggest that this extra clearance required because of sway of vehicle can be taken as 1/4 of this because of leaning of the vehicle. 1/4 of EH into G. Therefore, if you combine all these, the extra clearance required inside the curve, extra clearance inside the curve is because of curvature, that is C square upon 8R, that is your overthrow, plus because of leaning of the vehicle, that is EH upon G, plus because of sway of vehicles 1/4 EH upon G. Outside the curve there is only one component, and that is end throw, L square minus C square upon 8R. Now here, as I told you, L is the length of the bogey and C is the distance between two bogey centers of the same car. Now this distances which are adopted on Indian Railways are like this. L is 21,340 millimeter for broad gauge and 19,510 millimeter for meter gauge, and C is 14,785 millimeter for meter gauge, for broad gauge, and 13,715 millimeter for meter gauge. Height of the bogey, H is 3,350 millimeter for broad gauge and 3,200 for meter gauge. Now the extra clearance required in different situations, and the first situation is between extra clearance between two tracks which are on curve. Now these are two tracks running parallel to each other and both of them are on horizontal curve naturally. So what should be the extra clearance required in these two, between these two curves? Now this extra clearance here in this case, lean because of curvature will not be taken into consideration, because when the two vehicles are moving the same time, there will be equal amount of lean in both cases, and therefore lean is not considered in this case, but extra clearance will be overthrow plus sway plus end throw. Now overthrow is c square upon 8r plus this is 1/4 of lean EH upon G, and this is L square minus C square upon 8R. Now this is the amount of extra clearance required on two parallel tracks which are on curvature. Overthrow plus sway plus end throw. Effect of lean is not considered here. When extra clearance required, when between the two tracks, when you have a structure between them, there is a structure here. Now in this case, two tracks are considered independently, and the extra clearance because of overthrow, end throw, lean, sway, all are considered and provided as in the case of a normal track on a horizontal curve. Third case is platforms. When track on the platform is also on curvature, then in that case we consider all these cases, that we consider the overthrow also, we consider end throw also, lean also, sway also, everything. But what has been observed in field, that if you take all these extra clearances required, then in that case there will be large gap between the footboard and the platform, and therefore what is suggested on Indian Railways is that the total extra clearance required on a horizontal curve should be reduced by 51 millimeter minus 51 millimeter for the clearance inside of the curve, and minus 25 millimeter outside of the curve. What does it mean? It means that extra clearance inside of the curve will be c square upon 8r plus, because of superelevation, EH upon G plus 1/4 EH upon G, that is sway, minus 51 millimeter. That is the clearance required inside of the curve. And outside of the curve will be end throw, L square minus C square upon 8R minus 25 millimeter. So that is the allowance given when you are providing extra clearance on a platform where track is on horizontal curve. Now to illustrate this, let me just take one example. And example is like this, that two high level platforms are to be provided on the inside as well as outside of a 2-degree curve on a BG track with a super elevation of 100 millimeter. What should be the required extra clearance for these platforms, both on the inside and outside of the curve? Length of the bogie is given as 21,340 millimeter and center to center distance of the bogie is 14,785 millimeter. Now radius of the curve is, it's a 2-degree curve, and therefore R will be 1750 upon D. D is 2 degree and therefore it is 875 meter. 875 meter is the radius. Now extra clearance required. Extra clearance required inside of the curve is C square upon 8R plus EH upon G plus 1 by 4 EH upon G minus 51. 51 is just to take care of the spacing between the footboard and the platform edge. Now C is given. C is 14,785 square upon 8 into R, 875,000. Convert into millimeter. Plus super elevation is also given, 100 millimeter. So E into height of the platform, that is 840 millimeter upon 1760 plus 1 by 4 of this distance, that is 100 into 840 divided by 1760. Now here we are not considering height of the bogie because we are concerned about the platform. So here height of the platform is considered. Minus 51. So this is the extra clearance required, and this is approximately 42.88 millimeter, or you can say 45 millimeter. That is the, otherwise it is 96 millimeter in case of a normal track. Outside you have the end throw L square minus C square upon 8R and reduce it by 25 millimeter because of platform, and this value is L is 21,340 square minus 14,785 square upon 8 into R, 875 millimeter, 875,000 millimeter minus 25, and this value is 33.85 minus 25, that is 8.83, 8.83 millimeter. Let us say 10 millimeter. 10 millimeter. So this is the 45 millimeter inside and 10 millimeter outside. That is the clearance required for two platforms. Another consideration in horizontal curve is widening of the gauge. Widening of the gauge. Now what happens that when a train negotiates a horizontal curve on a normal tangent track, because of coning of wheels, the two wheels of the bogie, they are clear of the rail. They are centrally placed. But as soon as the vehicle enters a horizontal curve, this outer wheel will continue to move in a straight direction, in a straight movement, until the flange of this wheel strikes against the side of the rail, against the side of the outer rail. And then it continuously moves in contact with the side of the rail. That creates a rubbing action between the wheel flange and side of the rail. But because of this rigidity of the wheel base here, the rear axle or rear wheels take a different position. They move laterally inside. So that basically becomes the position of the rear wheel. Here, the inner wheel of the rear axle will strike against the side of the inner rail. And because of this, the flange of the rail continuously gets worn out. And because of this wearing out of the wheel flange and side of the rail, the gauge is slightly relaxed. The same effect can be obtained if you slightly provide wider gauge on horizontal curve, and that will depend upon the sharpness of the curve, the radius of the curve, degree of the curve. The equation which is used to determine the widening of the gauge or extra gauge width on horizontal curve is 13b plus L square upon R. This is the extra widening. Here, B is the wheelbase. B is the wheelbase of the bogie. R is the radius of the curve. Radius of the curve. L is called the lap of the wheel. Lap of the wheel. And this is calculated like this: 0.02 square root h square plus bh, where h is the depth of the wheel flange, h is depth of wheel flange below the rail head, below the top of the rail. How much is the wheel flange? D is the diameter of the wheel. Diameter of the wheel. Now this is the extra widening required on horizontal curve of radius r. But when you calculate this extra widening using this equation, if r is low, if r is less, means you have a sharp curve, then this extra widening becomes too large. Then in that case, there is some stipulation suggested on Indian Railways, and these stipulations are as given here. It says that for straight track including curves of 350 mm for broad gauge and 290 meter for meter gauge and 400 meter and more for narrow gauge, the gauge tolerance should be plus 3 mm to minus 5 mm. And for meter gauge and narrow gauge, you can see it is minus 2 mm to plus 3 mm or minus 3 mm to plus 3 mm. But when the curve radius is less than 350 meter on broad gauge or 290 meter for meter gauge and 400 meter to 100 meter for narrow gauge, then the gauge tolerance can be up to plus 10 mm on broad gauge line or meter gauge or narrow gauge line. So that means the maximum widening of the gauge or maximum slackness in the gauge is plus 10 mm. Now let me just take one example here to illustrate this widening of the gauge. How do we consider this stipulation which is given on Indian Railways? And the question is like this: the wheelbase of a vehicle moving on a broad gauge track is 6 meter. So B is 6 meter. The diameter of the wheel is 1524 millimeter and the flanges project 32 millimeter below the top of the rail. Determine the extra width of the gauge required if the radius of the curve is 168 meter. So here in this question, B is 6 meter, R is 168 meter, and let us calculate L. L is 0.02, square root of h square plus dh. H is 32 millimeter. Diameter of the wheel is 1524 millimeter. Now this is 0.02 square root of 3.2 centimeter square plus d 152.4 multiplied by 3.2. H and D are taken in centimeters. Now this is 0.446 meter. 0.6446 meter. Put in this equation. Extra widening is 13 into B 6 meter. L is now 0.446 meter divided by 168 square. 3.21 centimeter or 32 millimeter. Now you can see for a radius of 168 meter corresponds to almost 10-degree curve. 168 meter, the extra widening required is 32 millimeter, which is quite large. And if you provide this extra widening, wheels may go out of the gauge. What Indian Railway estimation says that for radius of 350 meter or less on broad gauge, the tolerance which can be is plus 10 millimeter. And therefore, extra widening on this curve should be limited to 10 millimeter. So friends, that is how we calculate the extra clearance on horizontal curve and extra width of the gauge on a curve in case of railways. Thank you very much for watching this video. If you have any doubt, you can write in the comment box.